This chapter on wiring fingers will zero out the bones and will wire the rotations of the bones to all of the custom attribute interface. This is obviously going to take a little bit of time, but it's well worth it for a really good hand setup. We need to zero out the rotation of these bones because we don't want them suddenly popping or changing. Currently, the values of all the spinners start at a value of 0, and that makes sense. But if I pick one of these bones and look at the y-axis, let's say, that we need to actually rotate this joint around, the y-axis current value is 16. If I wire 16 to a value of 0, this joint will suddenly pop straight. I could then sit there and play around with the math to get it back and know that I need to add 16.099 back onto it to get it to rotate back. But that would be even more of a pain to get everything back and wired together the way I want. The best way to do this is to use the zero out feature of freeze transform. Freeze transform will pop up this message, and that's accessed by Alt right-click in the upper left-hand quad menu. Freeze transform involves setting up another layer of controllers. You will lose any constraints animation that was applied to these objects. Sure. What it does is it builds a list controller on the position and rotation of the object. The first controller holds the values that it started at. The second controller holds the values as an offset controller. So all of the values of the second controller start at a value of 0 because they're additive onto the original one. We now know we actually have a 0 value to start with in this case. So we need to do that to all of the bones that are going to be included in the wiring process. So I'm going to select all the finger bones, Alt right click, freeze transform, and say yes. And it's now set up on all of them. We'll start with the index finger again for the wiring. Wiring is straightforward. Pick the bone, right click on the screen, pick wire parameters, and then find what you want to wire. In this case, the transform rotation, the 0 controller's Y rotation, and we want to wire it to something on the circle. In this case, under modified object, the pen attribute holder, hand controls, and we're going to wire it up to the index 01 parameter. The wire parameters dialog box shows up. On the left-hand side is the bone that we started with, in the finger. The right-hand side is the control object that has all the parameters on it. Comes up with the 2 already highlighted. You can now pick a direction of control or a two-way. I prefer not two-way controls because they do slow things down a bit. Very little, but they do slow things down a little bit more. And in this case, I don't want to be able to grab and rotate the bones on screen. So I want the index finger to control, or sorry, the index parameter to control the bone in the index finger on the Y. And then press connect. Let's test our spinner and slider and see what happens. You'll notice as the spinner moves, the slider moves, that the finger is rotating wildly out of control. This is a degrees radians problem again, and it's simply solved by saying deg to rad and converting this expression from degrees to radians. I'll press update again, and you'll now see that it makes a lot more sense. Now, as it turns out, it looks like the slider and finger are actually going in the right direction. I kind of expected when I scrubbed the value up that the hand would close. Seems to make sense to me. If you want to do it the other way around, you can, simply by putting a negative sign either in front of the deg to rad or in front of the index 01, and pressing update, and now it goes in the opposite direction. I want to leave mine this way. We need to do that to the rest of the fingers now. Finger joints. What I'm going to do is to simplify this rig a little bit. I don't actually have 3 joint rotation sliders for the index finger. I have the first joint, and then I have a second slider, and that's going to control these 2 joints, and then I have a splay which will actually rotate it side to side so I can spread the fingers out. A really good hand control system obviously would have one as well set up to be able to handle each joint independently. Again, wire the Y to the index 02 this time. Deg to rad. I'm actually going to copy that so I don't have to keep typing it. Connect. And I'm going to hook it up to the same thing, to the index 02 again. Paste my deg to rad in there. And now when I slide the second slider, both joints rotate. If I wanted one to rotate more than the other, I could have put a bit of math in there, multiplied the second one a bit if I wanted to. For the splay, I'm going to be using the Z-axis on the zeroed out controller and wire that up to the index splay, deg to rad, and check which way this goes. I would expect if the value goes up, it would move outwards from the rest of the fingers, and it does. I just need to go through the rest of the fingers and set those up now one at a time. What I'll do is, instead of doing that for you, I'll move on to setting up things like the splay. Or sorry, not the splay, the cup action. So I actually have a cup slider in here just to cup the hand. And what that is going to be an action of is, one, rotating this joint down and rotating it in a bit at the same time so that it cups down and around so that you could actually bend the hand and touch the thumb and the pinky finger together. So I'm going to start with the Y-axis, which is up and down. Oops. I'll start again. Y-axis down to the cup. Deg to rad. And it goes down like I would suspect it to. I'm then going to wire the X rotation and rotate it in a bit. Now I don't need to go through the wiring process with the quad menus again because I've got the X rotation right here in front of me. You can actually dig through and find any axes or any parameters that you want in the lists here. So I'm just going to pick the X rotation, connect it to the same item, deg to rad again, say connect. So you can see now that these two both are connected to this cup 1. Back to my cup. As it turns out, it happens to be rotating in the right direction. Now it might be rotating not enough on one axis and too much on another to get what we expect. You'll see it's rotating down a long way before it cups in. So we may not want it to do that. We may want it to actually rotate less down than rotating in. So I'm going to go back to this expression. If I pick the Y rotation and just multiply that by, say, 0.5, it now doesn't rotate down as far for the amount that it rotates in. And we get a nice cupping action happening. So we can bend the finger in. We can even get it to crush in a little bit by connecting in the Z rotation if we wanted. so that it crushes in side to side as well. Now again, this is way too much. We might want to multiply this by some small value, even just a 0.1, so that it tries to crush in and pull the finger in sideways a little bit. Now we can get a nice cupping action out of it.